Hi, my name is Deepak Tokas and along with me is Dr. Shweta Mahajan. Both of us are from Safe Water Network and today we are going to demonstrate how to use multi-parameter field test kit. This right in front of me is the multi-parameter test kit. It contains all the chemicals, glassware and other elements to be used for testing different water quality parameters. We will also be demonstrating how to check TDS and pH of water using these handheld devices. Now I am going to show you how to use this multi-parameter test kit. It has got different chemicals and each of the chemical is marked with different code. This booklet provided in the kit contains all the instructions to conduct different water quality tests. Here in the test kit there are different chemicals, different sizes of glassware, syringes, spoons, color comparator charts and the instruction booklet. Before starting, make sure the testing area is sufficiently clean, you are wearing hand gloves and washing your hands frequently after each test. Also make sure that the chemicals do not touch your skin or your eyes. So let's start with pH test. We have the sample test tube provided in the kit which has a mark of 5 ml. Then there is a reagent pH1 provided in the kit. So we will use this chemical test tube and comparator provided in the kit to test the pH of this water sample we have collected from the tap. I'll use this syringe and take 5 ml of the water sample and fill it in the jar provided. Now I will add 15 drops of chemical in the tube. Close the lid and shake vigorously until the chemical mixes completely. Now put this test tube in the comparator. Now match the color of the tube with the color provided in this color comparator and read the readings provided alongside. And as per Indian drinking water standards, the pH of drinking water should lie between 6.5 and 8.5. The next test we are going to show you is turbidity test. Turbidity is the opposite of clarity. If the water sample is turbid, that means it is not clear. As per the Indian drinking water quality standards, the acceptable limit of turbidity is 1 NTU and the permissible limit is 5 NTU. What that means is anything which is less than 1 NTU is good for drinking, but in the absence of a alternative drinking water source, you can drink water up to the limit of 5 NTU, but anything above 5 NTU shall be rejected outrightly. Shake vigorously the water sample to be tested. Pour well shaken sample in test jar up to 25 ml mark. Now place the sample tube on the small inner black circle on the comparison chart. View from the top of the comparator tube and compare the shade of the turbidity of the sample with different shades. Now I will show you how to measure turbidity. For that there is the comparison chart provided in the kit. Now we will take the water sample and we will shake it vigorously so that if there is any suspended solid which is settled below can mix thoroughly in the water. Now we will take 25 ml of the sample water in the test tube. Now Place the sample tube on the small black inner circle on the chart. Now view from the top of the comparator tube and compare the shade of the turbidity of the sample with the different shades. Read the NTU turbidity from the chart after arriving at the correct match. As you see, the turbidity in the water sample is less than 1 NTU because the sample we have taken is from the tap, which is municipality treated water. If the sample is taken from the surface water like ponds, you will see the water is very turbid and the NTU level will be much higher. Now we are going to test the total hardness of the water. Hardness is mainly because of the calcium and magnesium salts deposit in the water. Because of hardness, you can see the scaling of pipes and taps. Scaling is nothing but the white deposits you find on the taps at your homes, which is caused because of the hardness in the water. Now we will test the total hardness of the sample water. As per the Indian drinking water quality standards, the acceptable limit is 200 mg per liter, and in the absence of any other source, the permissible limit is 600 mg per liter. To test the hardness of the water, there are certain set of chemicals to be used provided in the kit, the instruction for which is given in detail in the booklet provided. Now we will take 10 ml of the sample water in the test tube provided. As per the instructions given in the booklet, we will first mix 1 spoonful of the chemical one provided in the kit. Mix thoroughly so the contents dissolve fully. Now add 10 to 12 drops of chemical 2. Mix well so that the chemical is dissolved fully in the sample water. If the color changes to the blue color, then there is no hardness in the water. But if the color turns red, as you can see in the sample, then there is hardness, and then we have to add another chemical, number 3, provided. We have to add the chemical drop wise and count the number of drops which you are pouring in the sample water. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. As you can see, the color of the sample has turned into blue now. Now we have to calculate the total hardness in the sample by using the formula provided in the instruction booklet, and the formula is 50 multiplied by number of drops of the last chemical we have used in the test. So as per the formula, total hardness in the sample water is 50 into 15, which comes to 750. So as you see, the hardness of the sample water is 750 milligram per liter. Now we will demonstrate how to measure alkalinity in the sample water. We will take 10 ml of sample water in this test jar provided. There are 3 reagents provided in the kit with code name AK4, AK2 and AK3L. First we will put 1 spoonful of reagent AK4 in the sample water. Now shake the test jar to mix the content well. Please note, if the expected alkalinity in the test sample water is more than 200, then you have to use reagent AK3L, otherwise use reagent AK2. Now we will add reagent AK2 dropwise in the sample water until the color turns from green to reddish violet. As you see, the color has turned reddish violet after adding 40 drops in the sample water. Now to calculate the alkalinity level in the water, we have to use the formula provided in the instruction booklet, which is 10 into number of drops added in the sample water. So as per the formula, the alkalinity in this water is 10 into 40, which is 400 ppm, which is parts per million. As per the Indian drinking water standards, the acceptable limit of alkalinity in drinking water is 200 ppm, and in the absence of any other drinking water source, the permissible limit is 600 ppm. Above 600, the water should not be taken for drinking purposes.
Hello, this is Dr. Shweta Mahajan. I will be continuing where my colleague Deepak left off. So the first test I will be doing with you is the test flow for fluoride in the drinking water. For that I have the reagents from the test kit all out here and ready, and we will be following the instructions from the booklet itself. So the first thing that we have to do is take 10 ml of our water sample in our test tube. So we are pouring water here into the 10 centimeter mark. Next we add just a single drop of this reagent called FD1 in this kit. This is supposed to give a yellow color to the water sample. So the color has developed as expected. Now we take another reagent labeled FD2B and add this dropwise to our sample until the yellow color disappears. The color is lighter with the first drop, lighter still, and the color has nearly disappeared after 3 drops. So it took 4 drops of this reagent to make the yellow color vanish from our water sample, and then we are supposed to add 5 additional drops of this reagent. We put this to the side. Now this is the reagent labeled FD3, a powder. We are adding 1 spoonful of this to our test solution, and if it gives a yellowish orange color, let us mix it vigorously and see what happens. A yellowish orange color means that fluoride is absent, but a yellow color quite similar to the one we saw before, that means fluoride is present. In fact, to quantify the level of fluoride, we take the last reagent, another liquid labeled FD4L, and we add this dropwise until the color changes to a peachy yellow, a light pink, light or a light peach color, and it is best to observe it against a white background. Remember to count as you go. So this, I don't know if you can see, but against the white of this table, I can see that it took 6 drops to change the color to a light peach. Let me add another color drop just to make sure. So I think I will go, 6 was the right number. And to calculate the level of fluoride in this water sample, we use the formula given in the booklet. So we have added 6 drops of the reagent to obtain the color, a peach color in the test solution. So to calculate, to arrive at our fluoride level in the water sample, we multiplied 6 by 0.1, and that gives us the answer in ppm. So this water sample has 0.6 milligrams per liter of fluoride, which is well within the acceptable limit of fluoride as defined by the Indian Drinking Water Standard. The acceptable limit is 1 ppm and the permissible limit is 1.5 ppm. So our water here, which we collected from the tap, has a fluoride content of 0.6 ppm. Let us now test for the chloride level in our water sample. We take this test tube, it has a mark up to the 10 ml level, and that is the amount of water we need. So let us carefully take water up to the 10 ml mark. Just a drop more. So here is a powder reagent CD1 provided in the test kit. 1 spoonful of this. A very light violet color has developed. Now we add the next reagent until this color changes to yellow. Dropwise we are going to add CD2. So it took exactly 10 drops of the liquid reagent to turn the sample solution yellow. Now next we have two reagents here, and we have to use either of them depending upon the chloride level in our water. Now the chloride level is unknown, and obviously we are testing for it. So we will find out if the chloride level is in the 50 to 1000 ppm level. We use this first reagent, liquid reagent labeled as CD3. If we expect that the chloride level is even higher than 1000 ppm, then we would be using CD4. So let us first try out CD3. We don't expect that the chloride level will be very high. We don't expect it to be higher than 1000, and let's see. And because this is a quantifying step, we have to count the number of drops of the reagent added. So 2 drops, there was a violet color and it disappeared. We have to keep shaking it after the addition of each drop, because as you see, there is a very vivid violet color as soon as the reagent touches the solution, but it disappears on mixing. So 6 drops, the color is disappearing slowly now. We expect that in the next couple of drops, hopefully. So the 7th drop gave us a very strong deep violet color, and our instruction booklet here says that what this means is 10 multiplied by the number of drops of this reagent will give us the concentration of chloride in ppm. So 7 drops of the reagent were added, that is, so the level is 70 ppm, 70 milligrams per liter of chloride in this sample. The acceptable limit for chloride in the drinking water is 250 milligrams per liter, while the permissible limit is 1000 milligrams per liter. Next, let us test for nitrate in our water sample. Now, the acceptable limit of nitrate in water according to the Indian standard is 45 ppm, and there is no relaxation. That is to say, the permissible limit is the same as the acceptable limit, which is 45 parts per million. Nitrates do not generally occur in surface or groundwater, but what happens is that excessive use of fertilizer in agriculture, nitrogenous fertilizers, leads to contamination of groundwater supplies with nitrates. The limit of 45 ppm is set because it has been found that at elevated levels it harms very young infants, that is, infants who are below the age of 3 months, if they consume it, say, in the form of water mixed with their milk formula. Let us begin our test for nitrate. We begin by taking 5 ml of our water sample in the test tube. Now add 1 spoonful of the reagent HN1 to our sample. And we shake it vigorously to ensure that the reagent is dissolved completely, and we let it rest for 5 minutes for the reaction to complete. So our water sample has been sitting for 5 minutes with the added chemical. It is time to make the next addition. This liquid reagent labeled HN2, HNT2, we add 3 drops of this. Mix it well, and then put this away for another 3 minutes. During this 3 minutes, we will have to keep shaking the sample intermittently. For the last step in our nitrate testing, we take this reagent HNT3 a full spoonful of this. We shake this, a deep pink color has arisen, and to allow for the color to develop in full, let us wait for another 5 minutes. Now the 5 minutes of waiting is done, and we see that there is a really deep pink color that has appeared in our water sample. So we know for sure that nitrate is in fact present. To find out how much nitrate is present, we will dilute this solution to 25 ml by adding distilled water. So right now this is near about 5 ml plus, and the test tube is provided with a mark up to of 25 ml indicating 25 ml, and we will add distilled water to the 25 ml mark. So perfect. Our nitrate test kit is provided with a color intensity chart, a color comparator chart. So what we do is we take the small comparator tube and add the colored solution to the comparator, and we place this on the color comparator chart. There is a white circle in the middle. We place this on this white circle and find the closest match to our nitrate sample solution, and comparing this here, the color intensity here, it seems that our water sample contains at least 40 parts per million of nitrate, which is quite close to the acceptable limit but still under. Thank you. Next, let us test whether our water sample has any iron content in it. The Indian standard says that the acceptable limit for iron is 0.3 ppm and there is no relaxation in the permissible limit. So, according to the Indian standard, drinking water should have a maximum of 0.3 milligrams per liter of iron. So, here we have 3 reagents to test for iron in a water sample, and a color comparator chart is also provided. Let us begin testing for iron in our water sample. For that, we will take 5 ml in the test tube. And then we add 15 ml of this reagent provided in the test kit. That's 15. We mix thoroughly. Let me put this away. And the second liquid reagent for iron testing, we have to add 30 drops of this. That's 30. Mix well. Side. And lastly, we take this reagent, it's in a powder form, 1 spoonful of this, shake well, and we put this aside for 10 minutes to allow the color to develop in full. So after waiting for 10 minutes, we see that there is a very faint tinge of color, a very faint brown color, and to see how much iron is actually present, if any, we will add this to the small comparator bottle, and we will place this and move it around the comparator chart, and the closest match in the color will give us the number value of the iron content. So we have to look from the top of the comparator tube, and this seems that maybe 0.05 ppm of dissolved iron is present in the water sample, which is well below the acceptable limit. We are going to see the content of free chlorine in our water sample. Now, free chlorine is not actually a contaminant of the drinking water. It is something that is added to the water by the municipal treatment plant. The role of free chlorine in water safety is a very critical one. What it does is that it prevents the growth of bacteria and other microbes in the drinking water until consumption. So, when the municipal water treatment plant has finished treating the water, the addition of free chlorine to the water is the last step they do before they send it out in the distribution lines. So, let us go ahead and see if our water has any residual free chlorine. Let us begin by taking 10 ml of water in our sample tube. So, we have here a reagent which, when added to water, should give a pinkish color to the water in case chlorine is present. So, just from seeing that the color of the water has stayed the same, we can tell that this actually does not have any chlorine content. If there had been any color development, we would have used this reagent to quantify the level of chlorine by multiplying the number of drops added of this liquid reagent FC2 multiplied by 0.1. So, to test for bacterial contamination in a water sample, we have here a sample bottle, a reagent, as well as test strips. So, the first thing we do is we take 5 ml of our water sample, measured via syringe. We add 5 drops of the hydrogen sulfide testing reagent to the sample. Mix it well. This is a reagent which, if any bacteria are present, the bacteria will react or process this reagent and produce hydrogen sulfide gas. So, now we are inserting a test strip very carefully into the bottle, 2 centimeters above into the bottle. There is a test field that should be not touching the sample, water sample in here, and we let it rest for about 10 minutes. So, if any reaction is happening, the hydrogen sulfide that is produced is going to react with the test field in the test strip. According to the Indian standard, there should be no bacteria present in drinking water, and the indicator bacteria that we test for is E. coli or total coliforms, both of which should be absent. So, now 10 minutes are done and we have removed the indicator strip from our sample bottle, and we compare it against the color comparator chart, which indicates, because there is no color development in the reaction field, that means that the water is bacteria free. There is no E. coli in this bacteria sample.
Next, we will show you how to use this handheld TDS meter. TDS is the total dissolved solids in the drinking water. TDS is the total amount of minerals, salts and metals dissolved in the water. To use this handheld TDS meter, we have to pour some sample water in the glass jar. Now remove the cap and press the on and off button provided on the meter to switch on the meter. Now immerse this meter in the sample water up to the maximum immersion level shown on the meter. Stir gently until the reading stabilizes. When the reading stabilizes, press the hold button to view the reading outside of water. Now, before putting it back, shake off the excess water on your meter. As per the Indian drinking water standards, the acceptable limit of TDS is 500 ppm, and in the absence of any other drinking source, the permissible limit is 2000 ppm. Above 2000, the water should not be used for drinking purposes. Next is the handheld pH meter. The pH meter comes with the screwdriver for calibrating the meter, the instruction leaflet and the buffer solutions. We can use these buffer solutions to calibrate the meter before using it on the sample water, and we can use this screwdriver which is used for calibrating the meter, and the instructions are given in detail in the leaflet. Now, to use the meter, you have to slide the button given on the top of this meter to switch it on. Now remove the cap and immerse the meter up to the maximum immersion level in the sample water and stir it gently until the reading stabilizes. After few seconds, once the reading stabilizes, you can read the pH level of the water sample. Now, before putting it back, you have to shake the excess water from the meter. As per the Indian drinking water standards, the acceptable limit of pH should be between 6.5 to 8.5. We use pH to measure the acidic level in the drinking water. Thank you very much. How to collect sample water from the tap? You take 1 liter of water, then turn on the tap and let it run for 30 seconds. After 30 seconds, you fill the bottle . Shake it well and again and again. Repeat the process 2 more times. Then collect the sample. Close the lid and put a sticker with following information on the bottle, which contains date, time, place of sample collected and GPS coordinates.